All right, today we are starting 4.2 day 2, so not really starting, but continuing section 4.2. Yesterday we worked on adding polynomials. Today we will work on subtracting polynomials. To warm up, we will add like we did yesterday. What's nice about these warm-ups is that they already lined up terms that can be combined for us. So we can go ahead and just start adding them together. Jakeem?
10a plus 2c.
Good. 10a plus 2c. The b terms cancel each other out. I believe we saw that possibly that same exact problem yesterday. All right, on number 2, it's important to remember that x squareds and plain x's cannot be combined together. So again, they lined things up nicely for us. We just need to combine like terms. Any volunteers for number 2? May? Beautiful. To subtract real numbers, you add the opposite of that number. So to subtract a polynomial, you add the opposite of each term of that polynomial and then simplify. So we're going back to the idea that subtraction is adding the opposite. All right, so we have directions on our notes that say that we are subtracting the polynomials. So that means we are subtracting the bottom one from the top one. So I would recommend putting the second one in parentheses with a minus sign out in front of it. That is what it means. We are going to subtract that whole thing. So the first one is not changing. 3y squared minus 5. But on the second one, things are going to change. Remember yesterday we did a couple problems where we had a negative sign out in front of the parentheses, and what did we do with that negative? Distribute it. We're going to do the same kind of thing here. So we are going to change all the signs so that we can just combine like terms like we did yesterday. So instead of a positive 2y squared, we have a negative 2y squared. Instead of a negative 3y, we're going to have a positive 3y. Should I put that underneath the 5? No. Probably not, because y and 5 are not going to be like terms. So if you want to rearrange these as you go, that's fine with me. Okay, and then we subtract a positive 4, so a negative times a positive makes that 4. Negative times a positive is a negative, and I will line that up underneath the 5. So we change this problem so that it's exactly like what we did yesterday. Once we've distributed that negative, then we can just combine like terms like we were doing yesterday. So 3y squared plus a negative 2y squared is just 1y squared. Negative 5 combined with a negative 4 is negative 9. And then the 3y, is there anything to combine with it? No, so plus 3y. If you write your answer in a different order, like y squared plus 3y minus 9, that's also fine. This bottom one is how you would usually see it written, like in a math textbook or an answer key. Okay, but I'm okay with either of these. Questions about example 1? What's nice about example 2? It's lined up for us, so that is wonderful. Same process. The bottom one's going in parentheses with a minus sign out in front of it. That reminds us that we are going to have to change all of the signs of the bottom polynomial. The top one we're going to leave alone. Instead of a 3, I would have a -3. Instead of minus 2y, plus 2y. Instead of plus y squared, negative y squared. Good. Top one stays, bottom one signs flip. Then we just combine like terms. Combine a 1 with -3. -2. Combine -2y, positive 2y. They cancel out. Combine 3y squared with -y squared. Positive or negative? Positive, so we put a plus sign. Okay, on this one also, if you, for whatever reason, wanted to rearrange it, you could. 2y squared minus 2 is also acceptable. Questions on those first couple examples? Okay. I want you to go ahead and try examples 3 and 4. Remember, the top one stays the same. The bottom one we put in parentheses with a negative out in front. And go from there. We'll talk about them in just a minute. All right, we said that the top polynomial will stay the same. Who can tell me what the bottom polynomial becomes on example 3? Keon? Good. Okay, so they were all positives. Now they're all negatives. They all changed in the bottom polynomial. Who can tell me what we get when we combine those? Kian?
2a minus az.
Good. The c's would end up canceling out on this one. Plus c minus c cancels out. So we just have 2a minus 8b. Wonderful. On number 4, the top stays the same. Who can tell me what the bottom one becomes? Delaney? What does the bottom polynomial become when we distribute that negative? Wonderful. Thank you. May, what do we get when we combine those? Beautiful. In this case, the positive and negative 2x's cancel out. We're left with 2x squared minus 2. All right, let's get back to it. On number 5, remember, we are subtracting the bottom polynomial from the top polynomial. So the top one stays the same. Okay, top one's the same. Natalie, what does the bottom one become?
4x squared plus 2xy minus 3y squared.
Beautiful. All the signs change on the bottom one. Then all we have to do is combine like terms. Keon, when we combine like terms, what do we get? So the original problem was subtraction, so we changed it so that we could just combine like terms.
9 squared.
Good. Subtract 1y squared. Good. So the two xy's in the middle, one's positive, one's negative. When we combine those, they cancel out. So there is our final answer. Questions about 5? All right, on 6. This process hopefully is getting a little boring just because it's so easy. Rewrite the first one. We're subtracting the bottom one. So when I distribute that negative, Jaquan, what does the bottom one become? Not the final answer, just what does this bottom one become? Good. All the signs flip. Okay, and I know Jaquan just said it, but Connie, can you tell us what we get when we combine like terms here? It'll stay negative just because we're combining. So if they're both negative, when we combine, it stays negative. Good. So that's a negative 5z. We treat this like a positive 1z. So negative 5 plus 1. What? So the 5's negative and the 1's positive. So we subtract and keep the sign of the bigger number. So if we take 5 minus 1, Connie, what do we get? 4. And which one of those is bigger? The positive number or the negative number? Negative number. So that becomes a negative 4z. And on the end, we combine 2 and a negative 1. Two minus 1 is 1. All right, so we just combine like terms to get our final answer. Questions on 5 or 6? Okay, we'll move it right along. Number 7, same type of problem. Keep the top the same. On the bottom one, we are going to be subtracting it. So we have to flip all of the signs before we can combine them. Logan, on number 7, when we flip all the signs of the bottom polynomial, what do we get?
10x plus 6y minus 12b.
Wonderful. Okay, all the signs change when we distribute that subtraction or negative sign through there. All that's left to do is combine like terms. Ellie, what do we get?
2x plus 11y equals 23z.
Not equals, but
Oh, not equals. Minus 23.
minus. Good. Minus 23z on the end. Perfect. Questions about 7. All right, number 8 is just a little bit different because they didn't quite line up our like terms for us. So there are a couple options about how you want to do this. If you rearranged the top equation when you rewrote it, sorry, not equation, polynomial. If you rearrange the top polynomial, that's fine. I usually leave my top one alone and adjust the bottom one, but it's personal preference. Okay, it's up to you. We are still going to be distributing a negative through the second polynomial to denote our subtraction. Ryan, what do we get when we do that?
What we're going to, it's going to be 2x plus 2x
So
2x minus 2x to the second power minus y. Just like that.
Okay, good. So the 2x squared becomes positive. The y squared is going to become negative. And I'm just going to scoot it down underneath the other y squared. What could I put in this big blank? A 0. If you want to put a 0 there, if that makes you feel better, go for it. You do not have to. The last thing we need to do is combine like terms. Jeriel, what do we get when we combine like terms here?
That whole thing.
When we combine like terms, yep.
7x squared
Good.
and really just y squared.
Yep, what would go in the middle of them?
14xy. We're gonna be adding that.
We're not changing that, so if we want to, we could put a big 0 right there. So is it going to change?
No.
Nope. So it just stays the same. That middle term stays the same. If there's nothing to add to it. Okay. All right, on number 9. What are they telling us to do? Simplify, yes, but add. How do we know that they want us to add?
Addition sign.
There's a big plus sign in the middle of those sets of parentheses. So this is another way of writing these problems. The sign that's in the middle of the parentheses is the operation that they want us to do. Now, if you want to leave these written out horizontally, you can. Okay, you can just, on the top one, just drop the parentheses. Personally, I like to line them up vertically like we were doing before. All right, so that was a good question. If there's an addition sign in the middle, we do not distribute a negative. That's only when they tell us to subtract that we distribute a negative into the second one.
So for 10 you would still distribute it?
Yes, on 10 we would distribute because they told us to subtract. But on number 9, it's going to stay the same because it's like distributing a positive 1. If there's a plus sign, it's like we distribute a positive 1, and a positive 1 does not change our signs. So you do not have to rewrite the first one top to bottom lined up. That's just how I like to do it. But when I go to combine like terms, Danielle, what do I get on number 9?
7x plus y minus 1.
Wonderful. Okay, if it's an addition problem, you don't change anything. You just combine like terms. Number 10 is a subtraction problem. So I still rewrite the first one the same exact way. When I go to rewrite the second one, I'm going to distribute the minus sign or the negative. So my signs are going to change. Dishon, finally. What is it going to be when we distribute that negative? Plus what? Good. All right. Next, we just have to combine our like terms. Jamal Dixon, what do we get when we combine like terms?
4x minus t minus
Minus what?
4.
Minus 4. Good. The homework for tonight is on page 148 again. You're doing some of the same problems. However, this time I want you to subtract them instead of add them. So you are going to be changing those problems. You should not get the same answers that you got on them last night. Okay, and then we're also doing 32 through 40 evens. Remember, when we do homework, we do the written exercises, not the oral exercises.